Good morning, students. Today we are discussing about unit number 2, chapter number 2. Particularly, that chapter is free electron Fermi gas. In our last class, we are discussing topic by topic. What is the main meaning of topic? We are discussing in our last class. Today, we are going to the depth of the subject in the present chapter, that is free electron Fermi gas. So what is free electron? Free electrons are nothing but actually valence electrons. Otherwise, outermost electrons can be called as valence electrons. You can give extra energy to those electrons. They have very low amount of energy. Based on that low amount of energy, the electrons are absorbed. The electrons are absorbed to break down the bond in between the central nucleus to the outermost electron. Bond is very weak. This energy is used to break down the bond. Where the bond is break down, then that electron is free in state. Those free in state electrons can be called as free electrons. That is free electron. After that, Fermi gas. What is Fermi gas? The Fermi gas are the set of electrons or fermions. Those are fermions. The set of fermions which obeys Fermi-Dirac statistics. Fermi-Dirac statistics. Those are called as fermions. Nothing but Fermi gas. Fermi gas is nothing but the set of free electrons. In that way, in our last class, ending point of view, I am discussing one main word that is called as Fermi energy level. What is Fermi energy level? The topmost completely filled energy level. What is Fermi energy level? Fermi energy level. So, which is first of all, it is a energy level. So, based on filling of electrons according to Hubble principle and Pauli's exclusion principle and Hund's rule point of view, you can fill the electron with respect to spinning of the electrons. So, first you can fill the electrons with clockwise direction, after that anti-clockwise direction based on the Hund's rule and Pauli's exclusion principle. So, on that way, electrons are filling at the lowest energy level. That energy level can be called as ground state energy level. Nothing but there is no extra energy are giving. The atoms are existing number of electrons. The electrons are particularly filled at the lower energy level or energy band. That energy band can be called as ground state. In that ground state, according to the lowest standard point of view, ground state, first excited state, second excited state, third excited state, go on that way. The difference or the gap existing between the two energy levels goes on increasing with respect to, because energy level in the lowest energy level can be called as ground state energy level. This is first excited state, this is second excited state, this is third excited state. So in this way, all electrons in the atoms are occupied in the ground state only. You can give the extra energy to the atoms. These electrons are occupied or absorb the energy and goes to the higher level. Nothing but the energy level between ground state to first state may be 2 electron volts, first to third 3 electron volts, first to fourth 4 electron volts. Suppose you can give the extra energy, E is equal to h nu in the form of energy radiation. E is equal to h nu. You can supply approximately some 4 electrons. So these 4 electron volts are absorbed by these electrons, directly goes to the third excited state. So the absorbed of energy. So how the electrons are going either first excited state or second or third excited state, depending on absorbed energy. Depending on absorbed energy. On that way, the electrons in the ground state going to the excited state based on absorbed energy. Based on absorbed. After some interval of time, these electrons are occupied by their original position. These are electrons are come back to its one ground ground state by emission of radiation. How much energy is absorbed? Same amount of energy is released when come back to its original position. This absorbed energy is released in the form of radiation. So radiations are occurred when absorbed electrons come back to its ground position. Some energy is released. That amount of energy must and should be equal to absorbed energy. According to your paper, laser, light amplification by stimulated emission of radiation. Laser topic is the main. This laser point of view, the basic phenomena is nothing but laser are existed by radiation. What is that radiation? The absorbed energy is released when electrons come back to higher energy level to ground energy. That absorbed energy release is called as laser. With respect to the population inversion based on some basic terms, that point of view, that emission of radiation can be called as particularly laser. In that laser, that emission must and should be stimulated emission, not the spontaneous emission. That is the laser point of view you can explain. So this is the energy level. So what the main meaning of Fermi energy level? Fermi energy level is nothing but, already I am told that the topmost completely filled energy level at absolute temperature. Particularly you must explain the temperature must and should be taken as at absolute temperature. So the topmost completely filled energy level. Filled energy level is nothing but each and every orbit filled completely, nothing but there is no extra electrons, there is no unbounded electrons, there is no free electrons, all are completely filled electrons. That energy level can be called as Fermi energy level. So according to the topic, our chapter is free electron Fermi gas. So you must and should, in this chapter we are discussing only about free electrons are existed in the lattice or crystal. So in this chapter we are completely discussing about free electrons. Free electrons are nothing but unbounded electrons, unbounded with the nucleus. Where the free electrons are created, you can give the extra energy. That amount of energy is utilized to break the bonds in between central nucleus to the outermost electron. They have the very weak bond is existed. That bond is broken. Then the bounded electron is converted into unbounded electron. That unbounded electron can be called as free electron. So based on that free electrons obeys the Fermi Dirac statistics. Based on that free electrons obeys the Fermi Dirac statistics. Nothing but characteristics, each and everything is obeys the free electrons by Fermi Dirac statistics. Those free electrons, those main particles can be called as fermions. The best example for fermions are electrons, neutrons, so on, each and everything. So best example for fermions can be taken as electrons and neutrons. So that is the Fermi gas. So here Fermi Dirac statistics obeys the particles can be called as fermions. That is the basic introduction about the free electron Fermi gas. So in this chapter, first topic you are discussing now. The first topic is called as allowed energies. The first topic is called as allowed energy. First topic. So based on this topic we are discussing mixing of number of particles, number of topics. So number of equations approximately 40 to 50 equations numbers is coming. So each and every one is clearly note that one. So the first topic is Fermi energy level. So I think Fermi energy level, here we are discussing the allowed energy levels. So for this allowed energy level, you can consider for this topic you can consider, let us consider a cubical system. A cubical system. So I am taking the one cube. This can be taken as origin. This is x-axis direction. This is y direction. This is z direction. This is z direction. So cubical system or cubical box I am considering. So this cubical box length can be taken as L. This cubical box length can be taken as L. So for this topic, allowed energy levels, we can consider a cubical box of length L. So I am taking the cubical box. This cubical box I am taking with respect to three-dimensional point of view. So x, y, z direction. This can be taken as origin. So the cubical box of length can be taken as L. So this is 0. This can be taken as L. So the length of the box can be taken as L. So within the box, the potential energy, well unknown topic. Within the box, the potential energy is always be 0. Within the box, the potential energy of the potential box is always be 0. That is the well-known term. According to this is taken according to the quantum mechanics. The particular topic is potential box. The particular topic is potential box. So on that way, allowed region point of view, I am taking, you can consider one cubical box of length L. So I am considering the potential box. This can be taken as origin. So within the box, only within the boundary, nothing but you can take the particle inside the cubical box, the particle having the potential energy, that potential energy value is always equal to 0. At what condition I am taking? According to the quantum mechanics point of view, with respect to potential box, so the potential box inside, the potential energy value is always be 0. I am considering, that is the known term. So that is the point. So according to quantum mechanics point of view, free electrons, according to quantum mechanics point of view, all free electrons obeys Schrodinger's wave equation. Already I told that in our last class, each and everyone must learn about Schrodinger's equation, must satisfy the Schrodinger's equation. Every free electron must obey or satisfy the Schrodinger's wave equation. What is the Schrodinger's wave equation? Everyone knows this is the, according to the question point of view is also, this is the long answer question. Derive Schrodinger wave equation in quantum mechanics. So del square psi plus 2m by h cut square capital E minus pi of psi is equal to 0. That can be taken as your equation number 1. Your equation number 1. That is the Schrodinger's wave equation. Here del square is nothing but Laplacian operator. What is del square? Del square is equal to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. That is the Laplacian operator. Laplacian operator. So, we are considering the one cubical potential box of length L. You can take any particle inside it. Inside the particle having the potential energy. I am taking the potential energy is psi. This pi value. According to the quantum mechanics point of view, that pi value is 0 with respect to potential box. With respect to the potential box, the pi value. So, from potential box point of view, pi value is equal to 0. Potential energy value is equal to 0. Then the equation 1 can be rewritten as Schrodinger's equation del square psi plus 2m by h cut square E of psi is equal to 0. This is Schrodinger's wave equation. This is with respect to potential and total energy point of view. According to potential box point of view, potential energy is 0. I am substituting in the equation 1. You get the result is Schrodinger's wave equation is del square psi plus 2m h cut square into E psi is equal to 0. E psi is equal to 0. That can be taken as your equation number 2. I am here. Del square is nothing but Laplacian operator. You can substitute in the equation. You get del square psi by dou x square, dou square psi by dou y square, dou square psi by dou z square plus 2m by h cut square E of psi is equal to 0. This is complete Schrodinger's equation according to the considering the cubical box having the length L. So, according to the potential box point of view and considering the cubical potential box point of view, the Schrodinger's wave equation in 3-dimensional point of view, I am writing the equation number 3, that is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 2m by x cut square into E of psi is equal to 0. So, according to this equation, solution is the solution of equation 3 is in every term they have the psi, wave function psi. So, the psi value can be written as equation psi of x, y, z can be written as is capital X of y, small y, z, small z. This is equation number 4. This is the solution of your equation number 3. So, this equation substituted in equation 3 must and should be satisfied. This is the wave function, single valued, periodical, and they have the boundary condition. So, I am substituting fourth equation in equation 3. Fourth equation in equation 3, we get the result is dou square psi by dou x square. So, psi is nothing but. So, finally, you get the result is 1 by x into dou square psi by dou x square. Dou square psi by dou x square. Particularly, this can be taken as small x. Similarly 1 by y, 1 by y into dou square psi by dou y square, 1 by z into dou square psi by dou z square plus 2m by h cut square e into psi is equal to 0, is equal to 0. With respect to energy point of view, you can write the equation in 3-dimensional point of view, nothing but x direction, y and z direction point of view. You can write the equation. You can write the equation like this: 1 by x into dou square psi by dou x square plus 1 by y into dou square psi by dou y square plus 1 by z into dou square psi by dou z square plus 2m by h cut square into ex plus ey plus ez is equal to of psi is equal to 0. This equation can be taken as your equation number 5. That equation can be taken as your equation number 5. That is the main Schrodinger's wave equation with respect to 3-dimensional point of view. Here total energy capital E can be taken as Ex plus Ey plus Ez in 3 dimensions, along x direction, along y direction, along z direction. That is the energy of the sum of the component along x, y, z. Here small x, small y, small z are independent variables. Those are not independent variables. Those are not depending on any of the quantities. Those are the independent variable. Each coordinate depending on must act separately equal to constant. So every term can be taken as the constant. So in that way I am representing with respect to dimension point of view, x direction, y direction, z direction point of view, I am representing the equation according to this: dou square psi by dou x square is equal to this term plus this one is equal to nothing but like this: dou square psi by dou x square plus here also 1 by x, 2m by h cut square into ex is equal to 0, nothing but 1 by x into dou square psi by dou x square is equal to plus term go to that side minus 2m by h cut square into ex. So dou square psi by dou x square is equal to x into minus x into 2m by h cut square into ex. This equation can be taken as your equation number 6. That equation can be taken as your equation number 6. Nothing but with respect to x direction point of view, the equation can be written as. Similarly, in y direction point of view, you can write dou square psi by dou y square is equal to minus 2m by h cut square y into ey. In z direction point of view, you can write dou square psi by dou z square is equal to minus 2m by h cut square y into ez. These 3 equations I am taking your equation number 6. So that equation number 6 is the solution can be written as. So in this way I am representing 3-dimensional point of view. I am representing each and every term according to the function. Given function psi can be taken based on psi with respect to potential box point of view. Within the box, the particle moving any direction or any way, the potential energy of the particle within the box is 0. Based on that, I am writing the Schrodinger's wave equation. The Schrodinger's wave equation with respect to zero potential energy point of view, dou square psi plus 2m by h cut square into E psi is equal to 0. This del square lambda square can be taken as Laplacian operator. I am applying that. So you get the equation number 3. This equation solution, in every term psi is there. I am assuming psi can be taken as x, y, z. This equation is the solution of your equation number 3. So this equation substituted in the equation, we get the result is this one. In this way, x, y, z components are always be independent variables. Those are not depending on. So every term can be balanced. On that way, I am representing with respect to x direction. 1 by x into dou square x by dou x square plus 2m by h cut square E psi is equal to 0. On equating them, you get the result is dou square psi by dou x square is equal to minus x into 2m by h cut square into E by. With respect to y direction, with respect to z direction, I am representing. That is with respect to x, y, z. First of all, I am assuming 3-dimensional point of view based on equation x, y, z are independent variables. So x, y, z are independent variables point of view. I am splitting with respect to dimension. X direction separately, y direction separately, z direction separately. So first you can learn about x direction. So you can learn about x direction or y direction or z direction. Nothing but I am explaining 3-dimensional is converted into, first of all, 1-dimensional point of view. I am clearly explaining about 1 dimension, either x or y or z. Combining these three is converted into 3 dimensions. So first we are explaining only 1 dimension. With respect to basic term, I am explaining 1 dimension is nothing but with respect to x direction you can take in. So according to the equation number 6, first equation with respect to x direction, this equation, that equation here psi is nothing but with respect to x direction point of view, this psi term can be converted into with respect to x, y, z direction point of view. This term is completely converted into dou square x, dou square y, dou square z. So based on your equation number 6, I am taking your equation number 6. What is the equation number 6? I am explaining 1-dimensional point of view. That 1 dimension must and should be taken as x direction you can consider. So you can x direction is nothing but in your equation number 6, 3-dimensional equations are there. With respect to x direction, the equation is dou square x by dou x square is equal to minus 2m by h cut square x into ex value. This is your equation number 6. The solution of your equation number 6 can be taken as some x of x is equal to a into e power ix k with respect to x direction kx plus b into e power minus ix into kx This is the solution of your equation number 6. So this can be taken as 7. This equation number 7 substituted in this equation, you get the result. So substitute equation 7 in equation number 6, we get equation number 7 in equation number 6, you get the result is sum. Here k is nothing but wave vector along x direction. So kx square value, you get the result kx square value is equal to 2m by h cut square into ex. 2m by h cut square into ex, where k is called as wave vector. Along x direction. In a similar way, you can take this equation, you get the result wave vector along y direction. This is a wave vector along z direction. According to the boundary condition, you can apply it. Boundary conditions we can apply. What are boundary condition? You can take the one-dimensional cubical box having the length is L. Nothing but the function psi of x, otherwise x value is equal to 0. At what condition? Boundary condition. At x is equal to 0 and at x is equal to L. 0 is nothing but one end, L is nothing but another end. So boundary is existed. According to your x direction point of view, you can take the boundary, potential box boundary. You can take here x is equal to 0, here L is equal to 0. X is equal to 0 point of view, this is small x, capital X value is 0, otherwise psi of 0. Here also capital X value is 0 or psi of 0. On that way you can apply the boundary conditions. What is that? Psi value is 0 at x is equal to 0 and x is equal to L. So these conditions are applied in your equation number 7. You get the result is. Suppose x is equal to 0. Anything power 0 is 1. A is existed. Anything power 0 is 1. B is it. X value is 0. Nothing but A plus B value is equal to 0. According to, you can substitute x is equal to 0. You get the result is A plus B is equal to 0. This can be taken as your equation number 9. In a similar way, you can substitute in place of x, you can substitute L. So A into e power I x plus, you can substitute L into kx plus b into e power minus I L into kx, that is equal to 0. This can be taken as your equation number 10. You can substitute the boundary condition, you get the result is. These conditions must satisfied if these conditions are satisfied when wave vector is, when the wave vector is, what is the wave vector satisfied? That wave vector kx value is equal to, these are satisfied as wave vector kx value is equal to, pi into nx by L. Pi into nx by L. This can be taken as your equation number 11, where nx value can be taken as 1, 2, 3 and so on. As you wish, you can take 1, 2, 3 so on. So the kx value is substituted in equation number 8. What is the 8th equation? This is your 8th equation. So substitute 11 in equation number 8. In equation number 8, you get the result is, in place of k, you get the result is Ex is equal to energy with respect to x direction point of view. Ex is equal to, you get the result is h cut square kx square by 2m. H cut square kx square by 2m. What is k? K is nothing but pi nx by L. You can substitute in this equation h cut square by 2m into kx square is nothing but pi square nx square by L square. Pi square nx square by L square. So finally you get the energy along x direction can be written as h cut square by 2m into pi square nx square by L. This can be taken as your equation number 2. That is energy along the x direction in the potential box, or you can consider the cubical box of length is L. So according to this, the x value, particularly x of x value, you can get the result is some c into sine of x into kx. This is your equation number 13. That is your equation number 13. So that is energy along x direction of the cubical potential box. Ex is equal to h cut square by 2m into pi square by nx square by La. So on that way I am assuming or calculating by x of x, can you get the result is c into sine of x into kx. That can be taken as your equation number 13. That can be taken as your equation number 13. So in this way you can calculate along y direction, along z direction. You get the result. Based on this result, you can normalizing the function. According to quantum mechanics point of view, you can derive the equation. After derivation the constants, you can normalizing. Based on that normalizing, what is the constant values occurred, you can calculate. On that way, in a similar fashion, I am normalizing the function. I am normalizing the function. You get the result. In the equation number 13, you have the some constant. That constant value is c. What is the value of c? So that c value is in terms of length of the box. You can derive it. Length of the box you can derive it. So normalization point of view. Further normalization. Further normalization. Further normalization of the function. Normalization of the function x of x. X of x. X of x requires c square into integral of sine square n pi sine square what is the value, pi x nx by L into dx value is equal to 1. That is your normalization according to your quantum mechanics point of view. Normalization function can be taken as c square into integral sine square pi x nx by L into dx value is always be equal to 1. On the calculation, what the boundary condition with respect to x is 0 to L. You can calculating this equation, you get the result c value is equal to square root of 2 by L, equation number 15. So on normalization of function, you get the constant value c value is equal to square root of 2 by L is occurs. 2 by L is occurs. Then the function x value, x of x can be taken as square root of 2 by L into sine of x into kx. Sine of x into kx. So that is your function along x direction. Along x direction point. In a similar way, you can calculate y direction. Same pattern is occurred. In a similar way, you can calculate energy with respect to y direction. You can occur according to equation number 2. Similarly, from equation 12, you can write what is Ey value. I am writing. In a similar way, you can write Ez. What is Ey? h cut square by 2m into pi square ny square by L. In z point of view, h cut square by 2m into pi square nz square by L. So same derivation you can calculate. You get the result energy with respect to y direction point of view and z direction point of view. I am writing in a similar way from equation number 12. Along that equation number 12 representing along the x direction. In a similar way, I am writing along y direction, along z direction. So on that way, you get the function also, y of y value and z of z value. You get x of x value is equal to c value is 2 by L. Here also 2 by L. Sine of y into ky, sine of z into kz. Same derivation is occurred. Finally, you get the result is, that is, these all values are substituted in your wave function, Schrodinger's wave function. What is the wave function you are taking? The wave function you are taking is psi of x, psi value. the wave function you are taking psi. What is the equation psi value is? You are taking the psi value is equation number 4. Equation number 4. What is equation number 4? Equation 4 is psi value is equal to x of x, y of y, z of z. This x, y, z are substituted in the equation. You get the result is, you can substitute it in that equation. You get the result is x of x. X value is root 2 by L sine of root 2L into root 2L into root 2L is nothing but 2 by L whole power 3 by 2 into sine of x into kx, sine of y into ky, sine of z into kz. This is your wave function. This equation can be taken as your equation number 18. That equation can be taken as your equation number 18. Ex value can be taken as 17. These are 17. This is your equation number 18. So psi of value is equal to, you get the result is 2 by L whole power 3 by 2 into sine of x into kx, y into ky and sine of z into kz. According to the corresponding allowed regions, E value, according to the corresponding allowed region energies, E value can be taken as h cut square pi square by 2m into h cut square pi square 2m into, here also L square is there, here L square is also there, into nx square plus ny square plus nz square. This is total energy with respect to 3-dimensional point of view. Then total energy E is equal to h cut square pi square by 2m L square into nx square plus ny square plus nz square. This equation can be called as wave vector. So h cut square pi square by 2m L square into k square or k bar square. That is, equation can be taken as 19. This is total energy expressions. This can be taken as your equation number 19. Equation number 19. Where k bar can be written as, what is the wave vector k bar? With respect to, wave vector is representing with respect to 3 dimension, x direction, y direction and z direction point of view. The wave vector is represented as, the wave vector is represented as k bar. The wave vector k bar is represented as pi into nx by L, pi into nx by L into I cap plus pi into ny by L into j cap plus pi into nz by L into k cap. That is our wave vector along the 3-dimensional point of view. This can be taken as our equation number 20. Here nx and ny, nz are non-zero numbers, particularly non-zero integers or non-zero numbers, non-zero integers. Nx, ny, nz are non-zero numbers and all are positive values. All are positive values. For the ground state, particularly all electrons are existed for ground state. For ground state, nx value is equal to 1, ny value is equal to 1, Nz value is equal to 1. So in that way you can calculate the energy of the ground state. You can calculate energy of the ground state. Energy of the ground state. This is the expression. Energy of the ground state is equal to h cut square pi square by 2ml square into nx value is 1, nothing but 1 square plus 1 square plus 1 square, 1 plus 1 plus 1 3, nothing but ground state energy is 3 by 2 h cut square pi square by m into L square. This is your ground state energy. 3 by 2 h cut square pi square by m L square. That is your equation number 21. This is energy represented as ground state energy. Energy is represented as ground state energy. That ground state energy value is obtained as 3 by 2 h cut square pi square by m into L square. M into L square. It has the degeneracy of the 3. Nothing but you can take the 3-dimensional point of view. The degeneracy number value is 3. It has the degeneracy of 3. Particularly the equation number from equation 21 point of view. It has threefold degeneracy. Threefold degeneracy. The degeneracy values can be taken as nx, ny, nz can be taken as 2, 1, 1. 2 all equivalent 2, 1, 1 has the same degeneracy. Otherwise 1, 2, 1. Otherwise 1, 1, 2. The three systems has the same equivalent values of energy. So nx, ny, nz will have the given higher allowed energy levels, which has a degeneracy depending on nx, ny, nz. So the degeneracy values are always be depends on nx, ny and nz values. So what is the fold of degeneracy depending on nx, ny, nz values point of view? You can depending on that one. So for example, you have the energy. For example, we have energy. E value is equal to 27 by 2. E value is equal to 27 by 2 h cut square pi square by m L square. Suppose we have the energy expression is like this: 27 by 2 h cut square pi square by 2 m L square. It has the fourfold of degeneracy. Particularly at this point of view, what are the values of nx, ny, nz? What are the values of nx, ny, nz? Particularly this point of view, nx, ny, nz values can be here. 27 is nothing but nx square plus ny square plus nz square is equal to 27. Nothing but nx square plus ny square plus nz square is equal to 27. On that way, nx can be taken as 3, ny can be taken as 3, nz can be taken as 3. So 3 square plus 3 square plus 3 square, 27. So nx, ny, nz are 3. Otherwise, you can take 1, 1, 5. 1 square plus 1 square plus 5 square, 25, 26, 27. 1, 5, 1. I am taking the nx, ny, nz values. here I am explaining fourfold of degeneracy R. So on that way this equation is satisfied. Nx is equal to 3, ny is equal to 3, nz is equal to 3. 3 square plus 3 square, 9 plus 9 plus 9, nothing but 27. Otherwise I am taking 5, 1, 1. 5 square 25 plus 1 plus 1, nothing but 27. In a similar way you can take the nx, ny, z probabilities can be taken 1, 5, 1, nothing but 1 plus 25 plus 1, also 27. Otherwise 1, 1, 5. So 1 plus 1 plus 25, nothing but 27. How many possibilities are there? 4 possibilities are occurred. 4 possibilities are occurred. So here it has fourfold of degeneracy is occurred. So what are the possibilities are created? That number of possibilities can be taken as degeneracy, values are degrees of degeneracy. So in that way I am taking allowed regions. Allowed regions I am explaining with respect to first I am explaining one dimensional point of view I am explaining, nothing but especially I am taking x direction point of view I am explaining. In x direction point of view I am explaining. After that we are going x, y, z individually I am separated. Suppose first I am explaining x direction, what the result is occurred, same result is along x direction, along y direction is occurred, same result along z direction. These three are always be perpendicular to each other. In that way, in three dimensional point of view I am taking one assumption. What is the assumption? The basic point of view, you get the result is, first of all you can assume one cubical box having the length is L. In that potential box or in that cubical box the potential energy is 0. So at what condition I am taking? With respect to the Schrodinger's wave equation, particularly one dimensional potential box, it. Within the box they have the 0 potential energy. At the end boundaries they have the maximum potential energy. Suppose you can assume the particle is existed in the box. You are assuming the particle is existed in the box. So on that way you can assume it inside the box is potential energy 0. The Schrodinger's wave equation is converted into some equation. In the Schrodinger's equation Laplacian operator is there. In Laplacian operator dou square psi by dou x square, dou square psi by dou y square plus dou square psi by dou z square. It is a three-dimensional point of view you can explain. So on that equation I am reduced into one dimension. That Schrodinger's wave equation is dou square psi by dou x square plus 2m by h cut square into E of psi is equal to 0. And that Schrodinger's equation is occurred with respect to the function psi. The psi is the solution of the equation. On that way psi can be assumed into three-dimensional x, y, z. This x, y, z I am converted into one dimensional. On that way allowed energy is calculated with respect to one dimension. That allowed energy expression is E is equal to n square h cut square by 2m L square. Is n is nothing but nx square with respect to y, ny square with respect to z, nz square. So total energy E is equal to Ex plus Ey plus Ez. In that way nx square plus ny square plus nz square is created. That is called as your n square. That is can be taken as your wave vector. On that nx, ny, nz point of view, how many possibilities are occurred? That possibility number can be taken as a degree of degeneracy, especially for ground state point of view. For ground state point of view, the energy value E is equal to, on ground state point of view, energy expression, energy E is equal to, you get the general expression is h cut square pi square by 2m L square into nx square plus ny square plus nz square. So according to the ground state level point of view, this nx value is equal to 1, ny value is equal to 1, nz is equal to 1. So they have only one ground state is occurred. That ground state values nx, ny, nz value can be taken as 1, 1, 1. Nothing but that 1, 1, 1 is represented as the ground state energy. That represented as the ground state energy. After completion of ground state energy, you get the ground state energy is occurred. 1 plus 1 plus 1 is nothing but 3 by 2 h cut square pi square by ml square. This is called as ground state energy. After that, I am assuming one more, that equation can be taken as nx, ny, nz value. After 1, 1, next excited state. These are the next excited state point of view. nx, ny, nz 2, 1, 1,